Wow, such a big crowd. It's definitely bigger than the meetups that I've done so far. I welcome you to my presentation. I must say, if I was in your place, I would have a hard time to choose because there are so many great talks. Specifically, I know I'm going to be watching the language servers one because it sounds really interesting. So it's really exciting to see so many people interested in OpenTelemetry. I guess like production incidents and debugging problems is a painful area for all of us. It's not fun to get up in the middle of the night and start trying to figure out what's happening. So hopefully, after this talk, you will learn something new, and maybe you will convince your team to adapt a new technology. My name is Konstantin. I'm a chief architect at Torq. My specialty is working at small startups. Currently, Torq is my fourth startup, and I really like starting things from scratch. You know, just opening up the repositories, writing the first line of code. That's what gets me excited. Torq is not a small startup anymore. We are like 100 people now, but we grew into it, and it's been an exciting journey. I have a fetish that I have to admit. I love reducing CI build times. You know, if I can spend like 5 days to reduce 5 seconds from a slow Circle CI build, actually we moved to GitHub Actions now. I kind of miss Circle CI though. It was really nice. Originally, I'm coming from like a low-level kernel drivers, Windows internals background. You know, debugging and writing in C, pointers and stuff. Thank God I don't have to deal with pointers anymore because Go is great, and it's really fun experience working with it. Small slide about Torq. We are building a security product. It's a no-code security automation platform. It allows security professionals to build automations. Basically, apparently, many people don't really like coding. They prefer visual interface to solve or automate their problems. You can think of it like Zapier, but for security people. It allows integrating with different security products, creating chatbots, and like an IDE with autocomplete, syntax highlighting, and so on. So let's dig in. How do you debug applications? Obviously, with logs. Logs have been around since forever. Actually, it's not quite true, because when you are developing locally, you have the interactive debugger, GDB, or in Golang, you have it built in, VS Code. It makes debugging really easy. You can step into function calls. You can watch variables. And it's all great when it's on your machine. However, life is not that perfect. And eventually, code leaves our machine and goes to some server in the cloud, someone else's machine. And then it's much more challenging to debug bugs or problems that may happen. And they always do happen. So you probably are familiar with the observability pillars. You have metrics, which is like how many requests a certain endpoint is being called, some averages, counters. It gives you a broad idea about what's going in your service. Logs, which are textual logs, textual representation that you add into your code, hopefully for your future self. So you can, when something happens, your past self left you a clue of where to look. And another thing that we are going to talk about are traces. Traces are kind of like logs, but I think they are much better, and I'll hopefully show you why. In a perfect world, you should build enough observability signals into your application, so when a problem happens in production, you should be able to resolve it without having to rebuild your code from scratch, or like having to to add some logs, roll it out, stuff like that. Because sometimes there are those sneaky bugs that happen like once every 10,000 iterations, and they are not easily reproducible. So then you would like to have as many metadata about the incident that happened. So logs are great, but you never have them when you need them. You never put them specifically in that place where a bug happened. And they're kind of not really great for understanding processes. Normally, you have a log here, a log there, and when you are looking at them, they're kind of standalone. You may implement some kind of linking between different logs in your system by adding like a request ID and being able to search for it. But that it requires kind of like a manual work, and especially if you're using different programming languages in your company and you have services, some are written in Node, some in Go, or God forbid Java, then it's hard to link them together. You need to synchronize all teams and tell them, hey guys, we're using request ID tag in our structured log. You should add it too to all the outputs. Another problem with logs is they kind of take a lot of space, and you need expensive tools to analyze them, like Splunk or Elasticsearch, which take a lot of resources. So I'm here to tell you that there is another way, a better way. For the sake of this talk, I've decided to build a demo. By the way, it's open source, and you can go to my GitHub repository and play with it. I said, hey, we don't have enough calculator apps in our world, and I'm going to make one, and I'm going to use all the cool technologies. It's going to be microservices, because microservices are great, and they're scalable. I'll probably get many calculations on my demo application. So it's built basically in two parts. You have the controller, which is a Go application, which is handling user requests. We have a pubsub, which is like Google's queue for asynchronous messaging requests. And we have some cloud functions, which is the mess evaluator. So the controller gets a request, a calculation request, it stores it in the DB, and then sends it via the pubsub to the cloud function, which does the calculation and returns the response back to the controller, which updates it in the database. As you may see, this is quite a complex system, and many things could go wrong here. So how would we approach to analyzing it, and what benefits will we get by having traces in such application? Yeah, these were the requests. Yeah. This is a screenshot from the Google Trace Viewer. Basically, I added traces. Some are automatic, and some are powered by middleware, or some are like ones I defined specifically in an application. And here you can see what is called a flame graph of requests, with the request traveling from my calculator service, some database storage, just everything that I explained to you about my example in the previous slide. You can see the entire trace code here. As you may guess, it makes understanding the whole story much simpler. You can see that each line here is called span. A span is like a function call or some unit of operation that I would like to document. In a distributed architecture, when you have several services, we have a service column here, which tells us what is the owner of this operation. In this case, you can see that the math cloud function is doing some calculations, reading from a pubsub and stuff like that. And another great thing about spans is they have a start and end time. So you can tell exactly how long each one took. And when you are looking at a trace, which is an end-to-end user story, you can see the bottlenecks in your code. Just to summarize what we said previously, a trace gives you a view of a lifespan of a request. So unlike logs, you don't have to do anything special to link together and understand the entire story. Usually, it represents a user flow through the application, some long-running process, and I mean, you can have traces running across multiple days if you are doing some waiting or some long-running calculations, or your flow may not be necessarily reactive. This is specifically great because it's a concept and it's a protocol that is supported across several programming languages. Let's talk about OpenTelemetry. So what is OpenTelemetry? OpenTelemetry is a cloud foundation project. It's actually the second most popular and most actively maintained. The goal of this framework is to provide a unified approach to both logging, metrics, and tracing. At the moment, the tracing aspect of this project is the most developed, and OpenTelemetry, I would guess, is most known for tracing. The goal is to provide excellent tools, excellent SDKs for multiple programming languages that let developers, us, use it easily and get value really fast from it. So you can use OpenTelemetry in Go, in Java, in Node.js, and then see the entire flame graph of your requests in a single point. If you're running on cloud, on big cloud provider like Google, for example, many of their lower level, like layer 3 or 4 services also emit traces using OpenTelemetry, and there is an amazing integration between your applicative traces and the traces that are provided by the infrastructure. If any of you are using service mesh software like Linkerd or Istio, they also have traces built in that will enrich the view and will provide you more information about what's happening inside your program, inside your distributed application. Just some basics so we are aligned about what we're talking about. So a trace represents some kind of process. A span is a single unit that belongs to a trace. The trace is like its father. A span can have a name. It usually has a name, some descriptive name. It can be either the endpoint name, or you can choose the name for your algorithm or some calculation that will give you clues when you are looking at it later in the middle of the night and trying to understand what's going wrong. The great thing about spans is they have attributes. So you can attach key value. Think about it like structured logging. You can attach key values, ID, username, whatever, something that can be used later to search. A common use case is like a user reports an issue and they send you a screenshot of your application. You can attach like a unique identifier on the bottom of the screen and tell them, for reference, use this number. They can give it to you, and it could easily be an attribute in a span that you could go to your backend, search for it, and find the issue that the user is talking about. Another cool thing about spans is they can have events. Think of events like textual message that has some description, basically a text, and it sits in a point of time. When you're looking in the viewer, you'll see an event appearing like a debug string. So it's kind of like all the stuff that you have from logs, you can also attach it to a span. And another thing about spans is that they are hierarchical. So a span usually has a father and some children. The deeper you go into the call stack, the more spans you will usually have. Another concept to know about tracing is a sampler rate. You don't have to store all spans. Something that is cool about OpenTelemetry is that they provide different collection mechanisms for you out of the box. So you can collect everything. You can collect a fraction of it, like every 5th request. Or you can define that you are interested in collecting only long spans, or spans that has error attached to them. And the concept that I'm not really touching in this talk, as it's more related to like DevOps and platform engineers, is the exporters, the backends that are receiving these messages from OpenTelemetry and processing them and storing them. If you are running on a big cloud provider, you already have one provided by you. Weird. We have an issue with the presentation. And there are some open source tools like Jaeger, which are able to collect traces for you. I guess they're trying to fix it. Any idea? I didn't touch anything. We can do single screen as well if it's easier. You think it's me? All right, it's fine. We can stay like this. It's okay. I'll find it. Sorry, small production incident, but we are back on track. So I hope so far it's clear that you should probably be using traces. They are great. They give you more visibility. It means more sleeping time at night when you're woken up from pager duty. Why are they calling me every night? I don't understand that. And they are also great to identify performance issues. If your customer is telling you that this page is taking too much to load, you can go back to your traces and see that you didn't create any indexes for this 1 million row database table, and you are doing a sequential scan. Well, who hasn't done it? And it's great to understand service-to-service dependencies, especially if you have a tool, if you are using a tool like Linkerd or Service Mesh. They create all this map for you, and looking at the graph at the UI, you should be able to tell where your packets are traveling. So how do you use OpenTelemetry in Go? In fact, it's super simple. You need to know like 3 calls. This is what you usually have in your main function. Just initialize a trace provider, specify the rate, some metadata about your service, like the service name, the version, something that will be attached to all the spans that are created and written by your application. And you'll configure the destination. In my case, since I'm running on Google Cloud, it's really simple. I have a module that was provided by Google. I can pass it to the span processor of the library, and everything just works. Most of the time, you'll be doing this. This is a function that I created. Usually, in a function, let's say we call it like the business logic, is doing something that is relevant for you and something that you would like to see when analyzing some issue. So you would start a span. You would give it a name. In this case, I called it insert user. And you can attach attributes to it. So in this case, I decided that putting the user ID is a good idea. You shouldn't forget to stop the span. This is what will mark its end. And that is how the completed add timestamp is added to it. And you will see how long it ran on your viewer. Another really handy tool for spans, like a feature, is that you can attach statuses to them. Basically, you have like a success or error, and you can record the error on the span. Since it makes perfectly great sense that you use this for debugging. Having a record of your error on the span is something that the infrastructure gives you. And you can then search for it easily, and some presentation layers even show it to you in red or something, so it's really handy. Spans work a lot with the context structure of Go. So most functions that are starting spans or doing something to a span, besides returning a span object, will return the context, a modified context, and you should pass it deeper to your code stack. This way, the spans become relatives. Like if I'm doing something, I created a span, and I have the DB operation that is also creating a span. The trace ID is propagating on the context object. So some cool screenshots of trace visualization and how you would use it to debug real issues. This is the trace viewer for Google Cloud. I think it's one of the better products for traces. Unfortunately, the trace viewers in general for OpenTelemetry are still not perfect. We, as avid users of traces, sometimes find things we wish we'd have, like something that, like search inside of a trace, as it seems like companies are not putting that much effort into improving the viewers. They're mostly working like on the SDK part, on the backend part. But me being, even though that I am a low-level engineer, I like my UI and I like to use the mouse. Sorry, Vim users. I like good UI, and it makes it really clear to see what's happening. So what do we see here? On the top, we see a bunch of traces that happened when I was playing with my demo application. On the bottom, you can see a breakdown of spans for a specific trace. We can, as you can see, it was a request that I made to the calculate method of my service. Span attributes that we mentioned earlier are great because you can see in the span tree, you can see the spans for a specific trace, and here you will see the attributes. So it's a key value. You will probably notice some like cloud stuff or some cryptic stuff that the infrastructure is adding for me. This is nice, but I'm not really sure how useful it is. In my case, I added the expression attribute, which you can see here. This is the data that I got from my endpoint, from the calculation request. It's really handy, so I can reference it in case there is some issue and I want to understand what expression caused my application to panic, like if you divide by 0. Another cool thing that Google offers for traces is integration with logs. Yeah, obviously, you probably have a large code base so now that is making a lot of logs, and you can't like throw all that away, but you still want to benefit using traces and logs together. So the way to do it is by using structured logging. In Google Cloud, it's really simple. You just add a field that is called trace ID with the trace ID of your current traced request, and the backend does its magic. You can see all the logs that are related to this span easily in the UI, and it's great because it's like the old and the new. You can get all the value from your logs in the context of the request of the distributed services, which is great. Some really cool integrations in Google Cloud, which you probably can get in other places, is that Google Cloud have a tool which is called Query Insights. Actually, Google came up with a protocol or an idea that you can add trace ID to queries and have them be linked to your traces of the application. So in this case, I made a list request, and I'm using Cloud SQL with Query Insights enabled. What this gives me is, you can see that these are some spans that the infrastructure added for me, and it's adding metadata about the query that I'm running here. This is really powerful when again, debugging production issue of some slow request, and out of nowhere you get this data, and you can see that you've done a sequential scan that is taking a lot of time. So you go and create an index or something like that. It's really handy. Basically, I think we can all agree that there is no such thing as too much observability. I mean, sure, it costs a lot, but maybe it's worth it because you are able to solve incidents for your customers much faster. So I hope that by now you are convinced that traces are great. And how do you go about adapting them in your organization? I think adapting traces is quite simple because there are multiple layers to it. I know there is a talk about auto-instrumentation later, which is really awesome. The idea behind auto-instrumentation is you just enable some flag, and you get traces for free, and you don't have to make any code changes. Maybe just configure the trace provider and the sampling rate, but you will essentially get traces for your handlers, like HTTP handlers, gRPC handlers, database operations, and you don't have to do anything. This is really great for adoption, and in like higher level programming languages like Python or Java, this usually comes out of the box. But let's say currently you can't get auto-instrumentation without doing anything in Go. What are your options? You are probably using an API gateway like Kong or Nginx. Most API gateways have native tracing support. So by turning a flag, you should be able to get some visibility on the incoming requests into your system. Just like that, small flag, and it's on. Your next step would probably be to add trace ID to structured logging, so you can enjoy having traces and enjoy the effort that you put in already by having logs in your system. The next step would to start using middleware for the common libraries. The OpenTelemetry community is amazing. They've built a lot of tools and a lot of middleware and integrations for many of the popular Go libraries that you are already using. It can be the HTTP server, the database server, the Redis client, you name it. There is probably already an integration. And even if there isn't one, you will probably be able, in like 50 lines of code, add your own middleware using their SDK. So all these 3 points are great because you don't have to force your engineers to do anything themselves. You probably already have like a common HTTP library or some implementation at your company that you are using with some same defaults that you're using inside. So just by going there and adding a middleware for tracing, you are already an adapter. Start playing with the SDK. The SDK is really simple to use. The APIs are very user-friendly. They have great developer experience, and you should be able to pick it up really quickly. Your next step, once you've done all the first 4, is to start to think about where you add spans in your business logic. It can be a calculation or some long-running process. Think where you are lacking the visibility. It's always great to look at previous incidents that you had in your company and think of what tools or what data would make analyzing them simpler and more pleasant. And if you are convinced that OpenTelemetry is great, be an advocate in your team. Start talking about it, show them a cool demo, and I'm sure they will be convinced. The first time I learned about tracing, I was mind blown because the flame graph and the extra data that you get is mind-blowing, and you don't really have to do that much to enjoy it. So like I said, middleware, I think, is the primary benefit, specifically in our case, for adoption. We have a bunch of implementations for these clients and servers in our company that we have with same defaults that are provided by the platform team. everyone who is building a new microservice or has a microservice written in Go and is just updating the Go module that we provide, they get tracing out of the box. They don't have to think about it. And they usually thank us later that we help them with observability on areas that they didn't think were needed or were lacking. This is just an example of how easy it is to add observability to your MOOCs router. You just install the Go package and use router use. Another cool use case that many people don't think about it is that once you have observability and spans everywhere in your code, you can start enjoying them in other aspects that are not related to debugging real issues. You can use them in tests. Think of traces like a spy function. If you are used to Java, so you have like mocking, and you can spy that a certain operation happened. With traces, you essentially have that. You're adding metadata to your code that you can observe also from your tests and build your test cases based on this. In this case, I have a function that does some stuff with traces. Me, as an engineer who built this function, I know that it should emit a test span in case it's done a successful operation. So Trace SDK, provided by OpenTelemetry, has a test collector that I can use in my tests to make sure that the spans that I'm expecting were actually created. Another really cool thing about testing is, well, testing is not really cool, but it saves you time for debugging. You probably are doing end-to-end testing. Unfortunately, you can't get away from having large tests that involve your entire system. OpenTelemetry posted a blog post, and there is an open source tool that is called Trace Test that you can use to do end-to-end testing on your system and build assertions based on traces. In this case, we built an assertion that trigger action result code will be HTTP OK, and we make some REST API call, wait for it to complete, and then using this tool, you can query your traces backend and figure out if it was successful or not. It's really handy. Now it's time for a demo. I hope it will work and we will not have any bugs. I mean, back to our calculator. Let's do some requests and see how we debug some issues. All right. So we have the calculator, which I hope you can see it. Yeah. Which is just like a REST API endpoint. Actually, it's using Connect build. By the way, if you are using gRPC, you should definitely look into Connect and the buff tool. They are doing an amazing job for the gRPC community. So I can send a calculation request to my server. And I get an ID. My service is deployed on Cloud Run, which is like a managed Kubernetes or something in Google Cloud. I guess like a more expensive Kubernetes. So I got an ID. I have a GET request. I hope you can see. No, too big. And you can see that I got the result of 5. And the ID is 86. If I go to Chrome, this is the trace viewer. I can look in the traces here for ID 86. Need to reload. All right, let's maximize it. Here is a request I just made in real time. You can see that all the calculation that happened. I'm using some middleware that is also logging the DB statement, so I can like really see the queries. This is super useful when you're debugging like listing operations in your app and you can't understand why they are slow. and then you look at the query that was generated by the great ORM that you are using, and you have like 7 joins and stuff like that, and a bunch of unindexed fields. And it's super easy. Just you can see this, the DB statement. No one really knows the queries that are emitted by an ORM. In next demo, I'm going to make, let's see, an error request. So I'm going to send, I cheated, so I created like, if I send an owner that is code error, it will fail. Yeah, as you can see, I got bad request. Let's try to find it here. I already created a filter for it beforehand. Because I'm using I'm using Connect, it has an OpenTelemetry middleware built into it, and it's already logging my status code. So if I look for it, you can see that I have one trace that failed, and it's painted in red. It's great because I don't have to like click on everything. You can see that the status code is 400, and some metadata that Cloud Run added, like the location and some cool stuff that I didn't think I need, but maybe I'll find out in 10 weeks in the middle of the night that this data is actually important. And I think the most impressive demo is code slow. I'm going to send an execution request. Go back here. So in this case, it's a slow trace. Let's see. Can I close this? Yeah. As you can see, I have a function, a span here that is called the laziness factor. It's basically a function that just does a random slip of between 3 and 10 seconds. You can see that in this case, my operation took a bit longer just because this laziness factor function waited for 3 seconds. So it's really cool. I can easily see, and I can go to the code and look for this span. Let's see if I can find it. Oh, this is the function. I wonder what it does. Oh, so it's creating a span. Thank God, past me thought it would be a good idea to add a span to a function called laziness factor. And you see it's doing some random number generation. It's updating it on the span, and it's saving it, and it's just slipping. Really handy. I wonder who thought it would be a good idea. So I hope you enjoyed this talk about OpenTelemetry, and I convinced you that tracing is good for you. And definitely it's good for future you that will wake up in the middle of the night to investigate production issues. And you also learned that you can use tracing for end-to-end testing. I mean, end-to-end testing is always a pain to set up, and they always fail and are flaky. Hopefully with traces you'll be able to get more stability into your tests as well. Thank you very much. We now have